Last time we figured out that atomic classes don't use synchronization. But if we take the AtomicInteger class, specifically the getAndIncrement method, it has to perform 3 operations atomically: read the current value, update it, and write it back. Let's understand how it works. The magic happens on the processor side. Modern processors support the compare and swap operation. Let's understand how it works. We have RAM with a memory cell where we store the integer value. It's called V. The compare and swap operation accepts the expected value A and the new value B. If A equals V, it swaps V with B and returns true. Otherwise, it returns false. This operation is performed on the processor level atomically. Different processor architectures have different instructions for this operation, but the key point is the same. But Java is a high-level language. We can't work with memory directly. We can. If we look at the AtomicInteger class, we see the unsafe class. This class contains low-level operations, including those for working with memory. And as the name suggests, you probably shouldn't use it yourself. Here we create an instance of the unsafe class. Here we have an int value of this atomic integer named value. And here we get the memory offset of this value field relative to the object. Now let's take a look at the getAndIncrement method. It uses the unsafe instance. You might think that this is the compare and swap native methods implemented on the JVM level in C++. And you would be right, but the actual native method is placed a little further. Let's get back to the first method of the unsafe class in this chain. Their compare and swap operation is hidden here. O is the object where the integer value is stored. The offset parameter can be considered as V, the value in memory. Here we read the current value from memory. It becomes A, the expected value. This one is the new value B. Delta is 1, as it's an increment operation, if you haven't forgotten yet. And you should have noticed that we get the expected value and try to perform compare and swap in a loop. The reason is that compare and swap is atomic. Yes, but the Java methods is not. Another thread might update the value between these two lines. Then the expected value A will be different from the one in the memory V, and the compare and swap operation will return false. So it will try until the operation is completed successfully. I hope now it's more clear. Just make sure to go through the source code yourself so you don't forget the details. Write in the comments what sophisticated topic you want to figure out next.